Okay, let's get ourselves going today. As we get going today, we want to pick up the threads with where we left off last time and kind of keep on talking about structural issues and really how you go through and frame things up and really how you start handling some unusual framing conditions and do that in the modeling tools because there's some kind of cool tricks to help you out and just ways of thinking about that. So let me kind of give you a rough outline of where we're going today. We're going to start with basically talking about the whole notion of basically framing irregular boundaries. So that's the whole notion of if you don't have kind of perfectly rectangular buildings that line up exactly with your column grids, how you start to handle that. But look at this whole notion where you have cantilevers and curved edges and just all those funny conditions where a perfectly rectangular boundary may not describe what you have going on in your building. So there's a lot of cases where that is true and we can do some things specifically to address that. We're also going to be looking at sloping surfaces. We've been looking at relatively flat floor surfaces so far. We'll look at that whole issue of really how we go through and handle, like roof beams and rafters and joists, things where we want to place a lot of structural framing elements but at an angle as opposed to having them be perfectly flat. I also want to take a look at the whole notion of what I'll call undulating surfaces. And that's surfaces that are not only simply sloping, but they actually have some sort of strange curvature and organic shape to them. And really what we can do about those in terms of supporting them either with beams or supporting them with trusses, because there's really a lot of cool things you can do to handle those. And a lot of interesting roofs we do now have those kind of shell shapes that kind of follow all sorts of interesting profiles. And you want to be able to take a look at that. Depending on how we're doing, we may get to lateral systems tonight, and if we do, we're going to be talking about the whole notion of braces and how we actually put in horizontal bracing systems to resist the lateral loads. More typically in our area for low-rise buildings, earthquake loads, but for high-rise buildings, thinking more about wind loads. And how we can then also go ahead and kind of look at the issue of shear walls as another way of providing that lateral reinforcement. And we'll just see where we get relative to the foundations. Because there's 3 different foundation systems I want you to know about: isolated footings, which we talked about so far, but we have slabs and slab edges. And we'll talk about strip footings, which are under walls that are continuous. So a lot of different little individual cases that will hopefully help sort of complete or fill out your knowledge of how you go through and do structural modeling. So let me go ahead and save that away, and we will get going. So let us switch on over, and I'm going to open up Revit, and you can open up your file if you want to, or just start a new file. But I just want to start taking like this funny notion of, just how you frame up things which are not completely regular. A lot of what we're going to do today actually sort of ties into your knowledge. If you're a structural engineer, you've probably had to kind of draw a lot of designs like this in terms of trying to figure it out. And really, we're going to find out. I'll say that's okay with that. Since I'm not on the internet and we're not quite sure why, we'll just let it go for now. And even in here, let me go ahead and open up a new model. Let's see if we can get this going. Yeah, but there's nothing magical about what the software is going to do here. It really comes down to your understanding of the physical reality. See if I can get that to stop bothering me. All these things it's going to complain a little about because since I'm not on the internet, but we'll see if we can get it to stop complaining so much. Okay. And so we have to kind of think about how the physical system is going to work and then ultimately model towards that. Because again, the modeling is not going to do anything magical. It can really only go through and model what can be built. So all the rules of physics are going to apply in terms of how we do this. So let us start by talking about these sort of irregular boundaries and some different sort of boundary conditions you may need to frame up against. So for example, one thing is this whole notion of really more of a cantilevered system and how we go through and do that. So let me kind of put together a real simple example that'll illustrate that, and hopefully this will shed some light on your situation. So for example, I could go through and make a very simple little column system like this, or grid system I should say. Let me go ahead and I'm going to put some grids in the other direction too. I'll put a grid in this direction. I'll call that A, just because I like to have that notion of the kind of intersecting numbers and letters. we'll go ahead and make B and C. So we'll put those in and get going. Now, in terms of thinking about this floor we're going to put in here and having to support that floor, I can go through and put the columns on this first level. That's going to work out just fine if I want to put them at those locations. So I'll put some structural columns in. I can, again, choose the type of column. I'll put them, since on level 2, I'm going to go in height instead of going depth. Put them up to level 2, and I'll just let them be those steel columns. And let me just say that it's going to be those multiple columns. I'll just put them at those grids. Here, here, and here. I'm selecting those grids in that direction, the opposite direction. So now I should have 6 of them at those different intersections. Okay, hopefully that's looking pretty good. Finish them up. The nice thing about doing things on the grids is if you do things on the grids, in theory, and hopefully in practice, what will happen is if the grids start moving around, the columns are going to move with it. And that's a nice feature because you have sort of a nice hierarchy of things that will all kind of stay hooked together. So let's think about going through and putting some sort of a cantilever like in this building somewhere. So for example, let me put a floor up on level 2 and see if we can sort of introduce a case where we'd have to have a cantilever. So, for example, I'll put a floor in here. I can even make it a structural floor. The only difference between a structural floor and an architectural floor is really that the structural floor has properties that can be used for structural analysis. So it'll have the choices about, if it's a concrete floor, it'll have the rebar choices, a lot of information about enabling an analytical model, which is all about then being able to take it to a structural analysis package and do finite element analysis with it. So what I will do is I'm just going to do this kind of relative to the grid lines now. I'll put something in here like that. I will go ahead and, relative to this, actually introduce a specific space where we're going to go through and cantilever. So maybe it's just sort of out in here, under a part of it or something like that. And let me trim that up just to kind of make it all look neat, because I still need one boundary. Now, this little guy over here, this triple line that's showing up right on the north side, that's the notion of the spanning direction. So you can kind of think about that. If you had a floor where there were a lot of joists in it, that would be the direction the joists would be running in. I believe in like a lightweight metal deck sort of floor, that's going to be the direction of the decking. So let me go ahead and change that to be sort of like a lightweight concrete on a metal deck. And we'll put it on down and say, okay, great, we're at level 2. So let's think about what we have to do here. I'm looking at those. Oh, that's actually, it's showing me, that's kind of interesting. Markers about, I think that's just calling out the breadth of the slab in terms of, yes, the boundaries there. We can just add some annotations to talk about sort of the slab and what the framing looks like in there. But if we were going to go through and frame up in a way such that we could go ahead and support this, okay, what we'd start to do is we'd go through and we'd put like beams basically between all those different columns, really separating and following the grid lines. So let's start with that. That's our starting point. Okay, so I'll come back here into the structural systems. I will say beams. Go ahead, and I'm not going to worry about the sizes again because we'll eventually get that figured out as part of an analysis. I can say that I want to put them on the grids. That's fine. I could also just go ahead and pick the grids. Either way, those will really have the same effect. So I'll just choose grids. I'll say I want to put one on this grid. I'm going to choose that I want to put one on this grid. This grid. So right now, I am expecting that I'm actually going to have 1, 2, 3, 4, 5, 6, 7 beams kind of created by doing that, all of the same size. If I say finish to that, it's going to put them at level 2. That's because I'm on level 2 right now, okay, with no specific offset. Actually, what I probably should have done, maybe I'll just do it in a second, is give them that little bit of an offset. And the reason I actually want to give them a little bit of an offset is that we, again, don't want them to intersect with the floor plane. We actually want them to be down just a little bit so that they're riding underneath the metal deck and supporting it, but not actually intersecting. Again, concrete can intersect, it melds together. Steel doesn't intersect, it rides beneath. So what I need to do is really take a look at this plane, this floor plane that we're going to be supporting. It has a thickness, it's 3 inches of lightweight concrete on a 2-inch metal deck, so that's 5 inches altogether. You can sort of see that down here in the thickness parameter. Okay, so what I want to do is take those beams and just press them 5 inches, so they're right underneath. So, to do that, lots of ways I can approach it. One way is to drag around and grab everything in the structure and then filter out things that I don't want to have selected right now. That's probably the easiest way to grab them. I can say just do a filter. It's interesting, the grids are there. Looks like I didn't actually create the beams. I'll think about why that is in just a second. Okay, placement level 2. Should be able to place them on the grids. I would expect it there. No beams were added. That has me sort of wondering what's going on. I'm used to being able to place beams in that way. Any ideas, guys? What am I not seeing? There's something that I'm not seeing that like it's going to stop me from doing it that way. Try this way. That should select that. Okay, that actually created a beam. I can sort of see it there. Any ideas why my on grids is not working right now? I should be able to just do right here. It's one of those days technology is going to vex me, so I'm not going to worry about it too much. Let me do it the other way. I'll go back to like 3D. We'll figure that should be working, and I'm not sure why, but let's go ahead and, unless I already put them in and created it the first time, which it looks like it did, and I'm just not seeing it, so it's not letting me create it twice, which is indeed a possibility. There are beams there. Okay, so at some point I did create the beams in there. So if I want to grab all those beams and suppress them, let me grab them this way. I'll sort of grab them in 3D. Okay. Let me get the structural framing. That's going to be the girders as opposed to the columns. That'll select just those 7 objects. And for those 7 objects, I could go ahead and depress either side of them if I want to have a slightly sloping beam, or I can depress the whole thing. So I can go ahead and set an offset, the starting level offset, or the ending level offset. Again, that's how I can manually make a sloping beam. It's not a very good way to do it. I'll show you a better way in just a minute. You can make a sloping beam. But if I want to just have them all drop down, I'll use the Z offset. It'll just drop it straight down. And that's where, something like, in our case, -5 inches will do us a good job. Apply that. And what you'll see is they're all kind of hanging just a little bit low. So they're actually looking pretty good for what we want to do now. Let me go ahead and put that floor back in there, though. So as we think about that floor and how we're going to support it, I am going to defer to you for just a minute in terms of, okay, for my structural engineers in the crowd, when you have to go ahead and frame out a cantilever like that, what are some of my options in terms of trying to make that happen? Because we need this thing we're just going to support out here to be kind of supported in some way. And let's think about what we can do. Okay, so if I don't want to put any columns out here, this is actually a pretty big cantilever. I'll be the first to admit that. I need to get some sort of support under here. What are my, any suggestions? Well, we could do that. That would actually help. Just to try to get it in the slab. How if I try to get some beam support under it? No, I'll take that. It's actually a reasonable way of approaching it. You could just try to do it in the slab itself to make a cantilever out there. How about if I want to get some beam support under here? What are my options for sort of trying to get some beams out there? Any options? Is anyone done framing like this? Yeah, we can do things like that. We could, for example, a real good way is sort of take this beam, the beam which is up on the left-hand side, and sort of extend it out, okay? And then start building. Often what you'll do is you'll go through and extend something like that. Okay, super. That could then support even a beam that's coming across. We still need to kind of support this side over here. So in terms of doing that, it's kind of tricky in that I could try to tie it back to this beam right here, and that would sort of work, but it's kind of a big moment connection there. It's, you know, as a simply supported beam, it would be kind of hard to do. So the more common thing we would actually do is go through and create some sort of beam that actually ties back in further to the structure, so that we can actually like have something that comes out across. So let's kind of think about how you might do that. To the extent that I want to go through and take this one and just drag it on out, that's actually pretty good, you know, in terms of what's going on. If I am going to have it dragging out there as a cantilever, I'm going to have to change my column a little bit, though. It can't go up through the beam. It's now going to have to come underneath it, and that's going to be okay in the scheme of things. In terms of supporting this piece out here, what I'd really like to do is actually tie back in somewhere further into the structure. Okay? Now I could tie all the way back. I could tie part of the way back. If this were not steel, if it was wood, we'd be using a rule that would say, oh, if you cantilever about 1/3 the distance of the total length that's kind of supported back on the other side. So kind of a 1/3 to the other side. Yeah, steel actually has a lot more support to it in terms of being able to go ahead and support cantilevered loads. It's really sort of more durable in terms of what's going on. So I can approach this a couple of ways. One thing I might do is say that, you know, I'd really like to go through and have, see if I can grab this beam. So I can grab the beam, do it that way. I'd like to copy it and kind of put it over here. Okay, that's not too awfully bad, but we're not quite in good shape yet. Let me kind of zoom in and show you why. In fact, I'll even hide that again just so we can sort of see this a little bit better. My problem is right there at that corner. You're back over here, we're going to be okay. I can sort of lower that down and sort of have it on the bottom of the connection. Over here, this one I'm sort of in trouble with because I can't really have two things that are sort of passing through each other. So what am I going to have to do? I'm going to actually have to lower this beam and have this one coming across it. Okay, and that'll actually work out for us. So what I can do is say that, you know, this beam over here, okay, as opposed to being -5 inches, what do I have to allow? This is like another 12 inches tall. So I have to basically lower it another 12 inches and make it -17 inches. Okay. It'll ride underneath. Okay. Architecturally, we're going to have to worry about that a little bit in terms of, okay, as we're thinking about the height of the doors and the ceiling and stuff like that. That's going to be riding a little bit low, but that's okay. And now we can go through and complete the structure out here by putting a beam that just kind of connects. Let me do a 3D snap. Okay, let's come over here. Okay, and now we can adjust the height as necessary. By default, I think it's putting it in at the 0, so if I need to put that down to -5 inches, I can do that just so it's all sort of level in terms of being underneath. Okay, and now we're in pretty good shape. That actually will go ahead and support the cantilever. So let me pause right there and see how that's sort of making sense in terms of doing something like that. It's all a matter of riding things over and under and trying to do stuff like that. But that'll actually support that. Like if we just do it in the slab itself, that'll do it. Yes? Yes?
Structurally, what would be the difference between how you have it now and instead of lowering one beam, just having essentially like 3 beams that intersect? Like cutting the one that you lowered in half.
Oh, that would actually, well, okay. If we put a column there, that'd be okay. If I had the 3 all coming together and trying to weld them together or something like that, the deal is, like, the load's either, it has to be supported on one or the other. You know what's going on. So what's happening here is we're saying the one going left to right, that's actually carrying the load as a simply supported load back to these 2 columns, and then this is coming down as a point load sort of in the middle of that beam. So it's supporting that. You know, so one's just got to dominate. Another way to do it, though, a perfectly valid way would have been to put a column right here. And then that would have supported in the same way this one cantilevered out, we supported it that way. So, different choices. Yeah, It's kind of tricky in terms of thinking about that. What will happen on things like this often is, as you go through and we set up stuff like this, we now have, these different sort of systems of the beams, and we can start thinking about now how we want to start framing up the joists within here. What will happen is, under the steel deck, okay, this steel deck is probably given this span, it's going to need a little intermediate support, because typically, the steel deck between like 5 or 6 feet, it doesn't, you don't take it so far before you sort of introduce some intermediate support. So if I want to put some intermediate supports in here, given the heights, I would think about actually running them left to right so that they can all ride at the same height, because I'm trying to avoid that lower piece down there. Okay, so I can have them spanning across here. There's a number of ways you can do that. And so what I mean by in terms of doing that, in terms of framing up the floor, it'd be something like this. So we have beams. So let's stop on the beams. How's the notion of beams and how I'm putting them at different heights? How's that resonating with you? Is that kind of feeling okay? Okay? Yes?
What's happening at the intersection of that beam and column that you just, or the beam you just extended?
Yeah. This guy over here, he's kind of okay. This guy over here, he's not so okay.
Yeah, with that one.
What I got to do there is I got to sort of change it up a little bit over here. Really, in terms of the way to think about this, if I want the continuity of the beam coming across, what I actually have to do is kind of stop that column underneath the beam. I need to put some plates in the beam to go ahead and kind of transfer the loads up through it. But what I would probably do here is, so I can get the continuity of the beam here, I would take this one, I'd lower the top, like 12 inches, or no, it's 12 plus 5 inches, because it's minus 7. It's, because of the two different things added together. Okay. In the beam itself, they sort of weld some plates right in here so that we have a nice kind of square connection to transfer the flange loads, and then we place the next column on top of it. Okay. So that'll work out okay. Good question, because that's actually the weirdest connection in this right now. So once we got that, we're ready to start thinking about, this notion of how we can go through and frame in the other direction. Beams are sort of simple elements. Beam systems are combinations of beams that all sort of work together. So for example, if we had a rule that said the longest span we could have on the concrete decking is 5 feet, we would put a series of elements going in the other direction every 5 feet, or maximum every 5 feet, so that the steel decking can be supported. And how we do that is actually, it's this thing called a beam system. Now, beam systems work amazingly like beams, except for the fact that you have to sort of choose some other element, or some element to use the standing element. So let's think. Before we do it, a couple things we can do. There's the notion of really what elements do we have available to working with in our model right now. And these 12 by 26 steel beams, they're okay. If I want to have something lighter weight, like an open web joist or some other steel size, typically these ones will be bigger and the cross ones will be a little bit smaller. If I want to do that, I'll load in some things. So there's two things I'm going to do to get ready to do this. One is I'm going to load in another kind of member. The other thing I'm going to do is actually change my work plane. What's happening right now, my work plane is level 1, since I'm in 3D. I'm going to change that to level 2, so that I'm placing them relative to level 2. So let me undo this and we'll head off in that direction. So two things. One is, let's fix the work plane. That's an easy one. We'll say set the work plane, level 2, okay. Now, we don't think about the work plane very much. Let me kind of show you where it is. It is really just some invisible sheet of tracing paper that, as we place different elements, it's going to be placed on that plane. So it's often sort of implicit in what we're doing, but if you want to show it, you can see it. That's where, as we place new elements, they'll show up. Okay, so I'll now have them showing up on level 2. In terms of making some more sizes available, here's what I would think about. Often on a steel frame structure, I will do this with like a lighter web, something like an open web joist, or just something that's lighter weight, because I don't, if I can get away with a lighter steel element, I will. I can go to, the Insert tab, let's say Load a Family. And in the Structural Framing, you'll find things like all these C channels and L channels and all these things that you're sort of used to, but you'll also find these like K-series bar joists. Those are the ones where, oh, they look like little open web elements. I'll just bring one in and show you. You have the choice of whether we want to bring in one that's made up of rods, kind of thin rod elements, or angles, like L-shaped angles to make up the web. I'll just do the rod one. Show you how it works. You open it up. They have sizes, just like all the beams do. The sizes are rated very much like the beams in terms of the first number being the depth, so whether it's 14 inches, 16 inches, 18 inches. The second number after the K, that's kind of the thickness. It's actually the stiffness. It's really how hefty that is, the weight per lineal feet. And, oh, if I go through, I'm going to bring in some nice 18-inch ones, so a K18 5. Again, I'm just guessing. We will eventually be able to calculate that. So we can place a single one of those if we want to. I can say, let's go ahead and place one of these K18s. And you'll see when I do. It puts kind of an open web joist in there. One of the reasons I like open web joists is that they're actually really good for allowing you to sort of start planning putting ductwork and mechanical equipment through them. So it's kind of cool that way. So I can have them bearing across, and that'll work out. I can place them individually like this, but I want to show you how a beam system works, because a beam system actually will make that a little bit easier. In that, if you have a regular pattern like this, you can say, let's make a system. Okay, it's going to be at level 2. You choose the type of element you want to put in there. And then we go through and, oh, it's a little hard to see because my screen is boundary, or is squishy. I'm going to draw a boundary. In fact, I could even pick the boundary. What I'll do is pick this column, or this beam over there, this beam over there. I'll do that. I'll just do that little section right now, and I'll have to trim that. The little triple line there, the parallel lines, that's showing us the direction that they're going to run. Let me trim it up and show you how it affects it. So if I do it this way, oops, I can also go through and put in an elevation change. Let me put in the same elevation change, that -5 inches, relative to level 2. And I'll say OK. And you'll see it'll put them all in there. Kind of resting beautifully right on top. So they're going in this direction because of that little triple line happening over there. If I choose them, I have to tab to get the whole system as opposed to an individual one. I can go through and edit that boundary again. That's removing it. And within the drawing tools, there's this beam direction. I can switch it over to go the other direction. And they would go that direction. So, how do you determine which direction they should go? Yeah, typically it's whatever the shortest span is. Whenever you get away with shorter, go for it. Yeah. Longer, deeper, more interference with other things. Whatever you get away with short, go for it. At least that's a good general rule of thumb. So let me go back in. I'll change that boundary again. I'll switch the direction over this way. Okay, now we've got a pretty neatly framed cantilever. We go ahead and put a beam system in here. We can put a beam system in there. We can really frame out the whole floor that way. Oh, it's interesting. What do you think? Zoom on out. That middle section, I definitely go left or right in here too. That makes sense there. This side over there, kind of go either way there. Yeah, it's okay to shift the directionality. That means that we're going to shift the decking of the concrete floor to kind of shift its direction. So you sort of get a little, it's like dealer's choice about whether you prefer to have a single direction. It won't make a big structural difference. It's really more kind of constructability standpoint whether you want that complexity or don't want that complexity. You know, sometimes we do things a little suboptimal, just to keep it very uniform because it'll be easier out in the field to go through and construct it. Okay, you were doing fine on this notion of cantilevers. That's looking pretty good. Let's talk about something. Actually, let's pause for cantilevers. Is that sort of feeling okay? Big thing is just finding a way to have things pass over each other. We'll take care of that. Let's let's look at another building shape that I think is actually kind of another interesting one that people run into all the time. Okay, I decided somewhere along the way, actually building a building like this down on 280 right now. Little storefront here. Oh, it's interesting. It's not exactly... I'm looking for an ellipse. I don't see an ellipse. We won't be able to do an ellipse. Let's just go do some interesting curves. Okay, so I'm going to go through and make something that looks sort of like this. Actually, let me just do the floor. I don't have to do the wall right now. But what I wanted to do is go through and let me take out that very straight wall right there. No, not all of them, just that one there. Okay, I'm going to replace it with more of a curvaceous wall. And this is the one that people sort of get themselves in trouble with. If you're thinking about some sort of organic structure that has an irregular form, this is going to be a pretty regular form, but we'll sort of see how it works. Yeah. How do you actually go ahead and handle things like that? Because at some level, you'll probably have a relatively regular grid back in this section over here. But over here, you'll probably have something a little bit different than that. And maybe come up with sort of a simpler example for you to think about, because maybe, you know, it all just sort of generalizes. Let's go ahead. I'm going to put a little floor in there just as an example on level 2. I'll make an elliptical floor and make a relatively small one. So the question is, how could you go ahead and frame up something like that? Okay, let's just stop and think about that for a second. Like, yeah. Any ideas? You could try something like that. That'd be kind of interesting. Although, we got to think about, you know, yeah, that radial, that's kind of interesting, but we can't ever think sort of these moments. We got to sort of think about something sort of simply supported too. So hold that thought. We'll think about doing something like that in just a second. Maybe we're going to do it. I'll just put some real simple columns in here as a starting point, or we'll put some grids in here. Let me be good. I'll be good about it and do it the right way, which is, okay, we'll say that great, we're over here. I'm on the second floor. Let me just do it over there. Zoom to fit. I can't put grids in a 3D view. That's what I was complaining about right there. Let's go ahead and I'll start by just doing something, you know, pseudo-regular. Like this. Maybe this will sort of give us started. You know, kind of like that. Okay, so far so good? I kind of shove that up a little bit too. Question for you. As we go through and put columns on there, do they have to be right at the outer edge of the building? No. I see some head shaking here. You're absolutely right. They don't have to be. Even the floor itself has a little bit of natural span. You can kind of count on it to kind of hang out a couple feet, you know, before you really have to worry about the structural support being there. And very often what happens is we don't put the columns right in the building. With the columns on the inside, the floor can span a little bit, and then the curtain wall just really hangs on the floor. It just is clipped to the floor and kind of makes a nice continuous sheath going down the outside of the building. So let me put some columns in here just to start with. I'll make them concrete just to be a little bit different. We'll load some families. And I'll get some structural columns. Okay, we'll get some concrete ones this time. Some nice round ones. And since I'm on the second floor, I'm going to go down this time instead of up. Okay, go down to level 1. Again, I can do that. Let's put them at the grid locations. We'll start there. So I'll say here, and here, and there, and there. And it looks like I'm not actually making my columns right now. At the grids. There. There. Kind of wimpy looking little 12-inch columns. We can fix that in a second too. I didn't say okay, did I? Third time's the charm. Make him a little bit bigger. Multiple at the grids. Actually, I shouldn't do that. Don't sing on video. That's like, this actually goes out to people. I feel like I can get away with it with you guys, but it's like, oh, it's gonna come back and haunt me. Okay, in a really bad video that'll make it viral because it's so bad. Okay, so we have the columns gonna hang around in here. We're doing pretty good. Let's think about what we're gonna do. Oh, the hard part's getting these extreme points, right? Yeah, and how are we going to go through and approach those? Because we can do some different things. Yeah, we could go ahead and we could put some columns out here somewhere. And what a lot of people will do is they'll just sort of approximate the curve. And that actually works out okay. You know, you could go ahead and take another column and drop it out here, close enough, and then put some beams in to basically sort of complete the triangle. And depending on how many we need, you know, it's okay that the ultimate surface is going to be curved. You're going to put as many segments in there as you need to. We could do something like that. And that would actually sort of work. Yeah. It may not be the most elegant solution, but it would work because, you know, relative to this big rounded column, I actually might want it to be very open and glassy and no sort of columns going to hang around right in the middle of my big kind of end of my ellipse. So let's think about another way we might do that. If we want to support that extreme point somewhere out here, but we don't want to go ahead and put a column there. Okay, what are other ways of getting some support out there to actually kind of keep that from falling down? So how can we get some support out there without actually having a column? Yeah, again, cantilever slab would work. Again, but that's okay. I'm going to put a beam in there to do the cantilever, but it's the same basic idea. Okay, what I want to do is I got to get a point out here that's supported. So how can I get a point out there that's supported? I can either get a column there, I can put some sort of cantilever thing out there. I can actually make that work. So let's think about this. So in the same sense, here's my guy like that. Okay, I'm going to put some basic beams in here. So for example, I could structurally get some beams. Let me go for the heavier ones now. I could go through and do this. I can go here to there, and that's pretty understood. I can put one over here to here, and that's pretty understood, okay, in terms of what's going on there. In terms of picking up these other points, I want to pick up that point. If I'm going to cantilever, what I have to do is basically have something the cantilever can pass over. Okay? So what you can do is something like this. If you can imagine a beam that is actually doing something like that, coming all the way across. Okay. Sounds kind of strange. Let's go and take a look at it in 3D. Hide that again. Okay, hanging around over there, that's looking a little precarious since it doesn't seem to be supported in any way. How can I go through and support that beam? It's going in the other direction. So, excellent thinking. You got the way it works now. So if I basically go through and get a beam over here, okay, I'm going to go in that other direction across, but I have to get it to pass underneath because I can't actually have it intersect. What I'll do is minus 12 inches or so, here to here, minus 12 inches on this side. Okay, so those are all looking pretty good. That's all supported nicely. You can sort of picture that thing standing. Okay, and now we can go through and do those other beams. Let's say again at level 2, I'll do the 3D snapping. I'll go from here to the end of this one. I want to snap to that. That's interesting. Oh, there it is. I want to have a snap point right there. That's going to bring up another interesting point in just a second here. A little messy. We'll talk about that in just a second in terms of what I'm actually snapping to. But you can go through and approximate the curve that way. And if that curve is still a little bit too approximate, you need it a little bit smoother, what you can start doing is actually putting other ones that are kind of coming across in between. You're going to break that instead of 2 segments into 4 segments, or as many segments as you basically need it to be. So, yeah. And the big thing is really just to sort of basically introduce structural support where it isn't by basically putting a cantilevering beam out there to go ahead and pick it up. Okay, so, I don't know. In terms of just sort of getting support where you don't think it necessarily can be easily, don't be afraid of it, because you don't need columns everywhere. You can actually have incredible segments which are supported by carrying the load back. Steel is an incredible material for doing stuff like that. Or the slab itself, as we really start getting to actually engineering the slab so we can go ahead and carry it back by adding close tensioning to it. You know, we can actually get it to cantilever quite a bit too. Okay, so that's why I encourage you. Don't think that everything has to be simply supported. You can actually get sort of incredibly irregular boundaries if you want to. Okay? So same sort of thing. We'll play all sorts of funny framing tricks in terms of if you have atria, if you have different sort of openings between the floors. The big rule on most openings is that if you want to go through and create an opening, for example, I want to have some atria between these different floors, the most common thing you'll end up doing is, something like this. I'll take some structural beams, and we'll go from here to here. I have my levels are a little wrong now. I'll fix that. Up to there. Let me kind of bring those up so they're back at 0. Okay. And if that's not the shape of the opening, if I have to sort of subdivide it further, go through and add some beams in the other direction. So it's really just here to here. And you can kind of frame that down to be just the size of the opening you need it to be. But in general, we tend to have, some sort of support really close to the edges, maybe not exactly at the edges, but it's going to be the same rule that applies at the outside edges. There's just going to be some support that's relative to what the floor can cantilever on its own. Putting those in there. So you often get sort of interesting little framing systems that go around things like that. And even for things like, don't worry about if it's a round pole, you tend to start framing around the round pole, trying to approximate it as closely as possible. Just as structural support is needed. So let's pause there. This whole list of floors and cantilevering things as you think about your buildings. Are there any unusual cases you're worried about, or anything you're thinking about relative to yours, or do you have sort of a pretty good sense of how you're going to go through and support that floor? So it depends on the complexity of your structure. The more organic, the more rounded, the more intriguing your framing system has to be sometimes. Yes?